This lesson is on converting units in the metric system by dimensional analysis. Dimensional analysis is a powerful tool we will use continually through chemistry, so you had better get used to it. Okay, first thing we need to be familiar with is the metric system. Again, the metric system has whole units. 10 to the 0 equals 1. So that means a whole meter or a whole liter or a whole gram, a single unit. And then we have multiples of those. So we have 1,000 unit to the kilo, and so a kilogram is a unit of 1,000 grams. A kiloliter is 1,000 liters. A kilometer is 1,000 meters. Or if we have a megameter, we have 1,000,000 meters. Or if we have a gigaliter, it's 1,000,000,000 liters, and so on. On the other side, we have fractions, and so a decimeter is going to be 10 to the minus 1, or a tenth of a gram if it's a decigram. A centigram would be a hundredth of a gram. A milligram would be a thousandth of a gram. A microgram would be a millionth of a gram. Nanogram would be a billionth of a gram, and so on. And we need to be able to convert any unit on this line into an equivalent of another unit on this line. For example, if I asked you 1 nanometer equals how many meters? Well, a nanometer is 10 to the minus 9th meters by definition, and so a nanometer equals 10 to the minus 9th meters. Literally, this says a billionth of a meter equals a billionth of a meter. And on the other side, if we ask 1 meter equals how many nanometers, again, a nanometer is a billionth of a meter. And so if we have a meter and we ask how many billionths of a meter are going to fit into that, it should be pretty obvious that you need a billion billionths to equal 1 meter. And if you want to do the math, you could take a billion and multiply it by a billionth, and that equals 1 meter. So a billion times a billionth, 1 meter times a nanometer equals 1 meter. For deciliters and liters, a deciliter again is defined as 10 to the minus 1th. So 1 deciliter equals a tenth of a liter, 10 to the minus 1. And 1 liter equals 10 deciliters, 10 to the positive 1 if you prefer. And so it takes 10 tenths to equal 1 whole. If we go from nanoliters to kiloliters, we got to think again through our numbers. A nanoliter is 10 to the minus 9th liters. A kiloliter is 10 to the positive 3rd liters. And so we have an absolute value of 10 to the 12th. And if we're going from a smaller unit to a larger unit, you can't have a larger number of a larger unit equaling a smaller number of a smaller unit. Therefore, this exponent needs to be negative. Anytime you go from a smaller unit, such as a nanoliter, to a larger unit, such as a kiloliter, you'll need a negative exponent. Likewise, if you go from a larger unit to a smaller unit, now we will need a positive exponent, so that is going to be 10 to the positive 12th. For megaliters and picoliters, a megaliter is 10 to the positive 6th liters, relating it to the whole unit, the liter, whereas a picoliter is 10 to the minus 12 liters. And so that gives us a value of 10 to the 18th if we think of our number line going from positive 6 to 0 to negative 12. That's going to make 10 to the 18th. And if we're going from a larger unit to a smaller unit, then we need a positive exponent. It takes a large number of a small unit to equal a smaller number of a larger unit. And then, of course, on the other side, we're going to a larger unit, so now we need a negative exponent. We will use this dimensional analysis for conversion of units. And this is how dimensional analysis is going to work. If I want you to convert 22 kilograms to grams, you're always going to write down the unit that you're given and its numerical value. So we have 22 kilograms. Then you're going to set up a conversion factor, or what we call an equivalent. And this is going to allow us to convert kilograms into grams. Those are the units involved. So those are the units that are going to show up in our equivalent. Always the unit you start with is going to go on the bottom. That way they're going to cancel out. Again, we want to get rid of the kilograms and find the grams. And so the unit you start with always goes on bottom so they cancel out. Then in the metric system, we can always put a 1 here and a 10 here. And we're going from kilograms to grams. And so that's 3 powers of 10 different. And since grams are smaller, we're going to the left on this line. That needs to be a positive exponent. And as far as the math, we're just going to take 22, multiply by 10 to the third, divide by 1. And that's going to give us 22 times 10 to the third grams. Converting to standard scientific notation, we only want 1 digit to the left of the decimal. So I'm going to change that to 2.2 times 10. If I make this number smaller by moving the decimal to the left, I got to make the exponent larger. So that is going to be to the fourth grams. Next one, if we have 320.2 milligrams and we want to convert milligrams into kilograms. A milligram by definition is 10 to the minus third grams. A kilogram by definition is 10 to the positive third grams. So we have to go from a negative 3 to a positive 3. That's going to be 10 to the sixth. And again, we want to put our number 1 on bottom and the units we're starting with on bottom and the number 10 on top. You don't have to do it that way, but I think it's easier. And then the unit you're converting into on top. That way milligrams and milligrams cancels. And again, this is going to be a 6. And again, we're going from a smaller unit to a larger unit. So the exponent needs to be negative. You need a smaller number of that larger unit to equal the larger number of that smaller unit. And so that's going to come out to 320.2 times 10 to the minus 6 kilograms. Again, to change it to proper scientific notation, we want just 1 digit to the left of the decimal. And so we're going to move this 2 places to the left, or we're going to reduce it by a factor of 100. So we have to increase the exponent by a factor of 100 or increase it by 2, and that will make that a negative 4. Negative 4 is 2 more positive than a negative 6. And again, units are kilograms. 2 more, make sure you got this. So here we have 2.12 megagrams. And we want to convert megagrams to milligrams. And so we want our megagram units on bottom, milligram units on top. There's 1 megagram for every 10. And now we got to figure out the exponent. A megagram is 10 to the positive 6th. A milligram is 10 to the minus 3rd. And so we're going to have a absolute value of 9. And if we're going to a smaller unit from a larger unit, that needs to be a positive exponent, so positive 9. And so that's 2.12 times 10 to the 9th milligrams. Megagrams having been canceled out. Next one, going from picograms to kilograms. Probably easier just to convert this to scientific notation to start with. So 1.2 times 10 to the 5th picograms, only 2 sig figs, so 2 sig figs. And we want to convert picograms into kilograms. And so we want picograms on bottom, kilograms on top, 1 and 10. A picogram is 10 to the minus 12th grams. Kilogram is 10 to the positive 3rd. So that gives you a absolute value of 15. And if we're going from a smaller unit, the picogram, to a larger unit, the kilogram, we need a negative exponent. So that's going to be a negative 15. And now when you multiply through, we can just add the exponents. A positive 5 and a negative 15 is going to give us 1.2 times 10 to the negative 10th kilograms. Again, picograms will have canceled out. And so that is dimensional analysis. What if we have two units or a ratio. If I want to convert millimeters per second to kilometers per hour, so I'm given meters per second, I want to change that to kilometers per hour. We're simply going to do dimensional analysis two times together. I've got a distance unit in meters. I've got to convert those meters into kilometers. I've got a time unit in seconds. I've got to convert that to hours. And so I'm going to start by taking my ratio, 1.2 meters per second, and write it this way and set up my equivalents. I'm going to use this one to convert kilometers or meters to kilometers. This one I'm going to use to convert seconds into minutes, and then I'm going to convert minutes into hours. And so there are 10 to the minus third kilometers for every 1 meter. There is 60 seconds for every 1 minute and 60 minutes for every 1 hour. Watch the units cancel out. We have meters and meters canceling out. We have seconds and seconds canceling out, minutes and minutes canceling out. So we are left with kilometers on top, hours on bottom, which is what we wanted to get, kilometers over hours. And if you want to see the answer, it's going to come out to 4.3 kilometers per hour. Next one, 19.3 grams per milliliter. How many milligrams per liter does that equal? So we've got a gram unit that we got to convert to milligrams and a milliliter unit that we've got to convert to liters. So a mass unit, grams to milligrams, a volume unit, milliliters to liters. So now we need two sets of equivalents. One to convert the grams into milligrams, and the other one to convert the milliliters into liters. Again, note the arrangement. If grams are on top here, they have to be on bottom here, so they cancel. If milliliters on bottom here, they need to be on top here, so they cancel. And 1 gram equals 10 to the minus third milligrams. And 1 liter equals 10 to the third milliliters. And when you multiply 10 to the minus third times 10 to the positive third, you're going to get 10 to the 0 or 1, or it really comes out to be the same numerical value. Turns out a milligram and a liter are the same difference in size as the gram and the milligram. Okay, last one. If I asked you how many centimeter cubed are there in 1 meter cubed? And so first thing I would do is relate the centimeter, not cubed, to the meter, centimeters to meters. And so for every 1 meter, there's 100 centimeters. Now that's not going to cancel the cubed, and so I'm going to cube the whole thing. And so when I cube the denominator, those two will cancel out. When I cube the numerator, 10 squared times 3 is going to give me 10 to the 6th, and centimeters cubed are going to give me centimeters cubed. And so that is going to come out to 1.0 times 10 to the 6th centimeters cubed. And so we are just relating the distance units and then cubing the whole equivalent to solve for this particular problem. Thank you for watching.